Good morning, everyone, and welcome to this webinar hosted by Thales and HashiCorp. My name is Chintan Gosalia, and I'm a senior solutions engineer at HashiCorp. Previously, I've also worked for Thales, so I'm super excited to be working on this webinar with the team there.
I agree. My name is David Madden, and I'm thrilled to be here with Chintan today to talk about applying roots of trust for DevOps secrets in Vault using an HSM. Today in this webinar, we're going to plan and discuss a number of things, including a very interesting challenge that we're seeing out there in the world with secret sprawl that a lot of our large organizations are running into. We're also going to talk about how organizations can address this with HashiCorp Vault Secret Management, and also how they can leverage an HSM as a root of trust to protect these secrets stored in the vault, as well as ensuring automation for DevOps. According to our friends at IDC, one of the things organizations see as they digitally transform is the shift from a service provider approach to a core part of the digital value chain creation, making DevOps, what Hashi and Thales do, a core asset of any business in the digital economy. So we're going to talk about this, talk about that impact to really every organization that's digitally transformed. So let's get started on this TalkingTrust with Thales and HashiCorp. And I think the first place maybe we do that, Chintan, is around secret sprawl, which is on a lot of people's minds today. Can you describe in a little more detail what's causing secret sprawl?
That's a great question, David. We all know that to thrive in today's digital economy, every organization is heavily investing into digital transformation. The goal of this transformation is to accelerate building and delivery of applications to its customers. And the two critical components to achieve this acceleration are, number one, transition to the modern data center that provides on-demand resources, and number two, adoption of agile and automated DevOps workflows. Now, this transition has created a unique challenge of secret sprawl. For example, as a team dynamically scales up the number of app servers due to increased demand, these newly provisioned app servers need username and password to connect to the database servers. A Jenkins servers may need to inject a GitHub API key in its CI/CD pipeline, or they may also have microservices that need tokens and certificates to securely connect and communicate with each other. The outcome is a lot more sensitive secrets to manage than they ever had due to the automated dynamic workflows. In a recent survey, 81% organizations confirm that they have experienced secret sprawl and worry about leakage or compromise of secrets that can lead to a breach. Traditionally, the organizations relied on storing the secrets in plain text, either in config files, application code, or even providing secrets manually by human operators. This was an acceptable risk in a static and high-trust network in the four walls of a data center. But the infrastructure in public clouds are no longer owned by application owners, and without any defined boundaries, networks are considered low trust or zero trust. So can't leave secrets in plain text in some files or code. What is required is a shift in our secret management approach, a solution that securely stores secrets and relies on service-based identity to deliver them to applications in an automated manner.
Right. Thank you, Chintan. So now that we understand why these customers are looking at secrets and using them in so many different ways, enabling them to really achieve the benefits of digital transformation, automation, and cloud native, now I think we should probably discuss more about how they should best approach implementing this in a secure and, of course, a scalable way. Can you share some details about how Hashi is approaching this?
Yeah, another great question, David. The challenges we discuss are why HashiCorp Vault has become a de facto standard for secret management in a multi-cloud environment with DevOps workflows. Its success can be attributed to its three core principles. The first one is extensible architecture. Vault supports a variety of secrets through its secret engines. For example, A PKI secret engine can dynamically generate digital certificates. KV secret engine can store any static secrets, and MySQL secret engine can dynamically generate MySQL database credentials. There is a secret engine available for any well-known type of secret and its workflow. This extensible and pluggable architecture allows Vault to provide a single pane of glass to manage any secrets in any environment. The second principle is its ability to secure with any identity. Vault integrates with pretty much all popular identity providers. For example, a client can authenticate with Vault using its GitHub credentials when requesting a secret in a development environment. The same client can use Okta or AD credentials when requesting a secret from a corporate network, or use AWS IAM credentials for a secret in the AWS environment. This allows Vault to provide secrets to any client in any environment. The third principle is its API-first approach. Every operation in the Vault is available through a CLI and API, and hence it seamlessly integrates with any existing human or DevOps workflow.
Nice. Now I see why organizations are adopting Vault to effectively manage their secret sprawl, with leveraging these capabilities. But doesn't that now make Vault a target as it now stores the crown jewels to the organization's DevOps infrastructure? Can you tell us how Vault can help address this risk?
Yeah, it definitely does. And to address this risk, Vault encrypts all its data in storage with an encryption key. These encryption keys are then encrypted with a master key, which is then protected by another key known as an unsealed key. This unsealed key can be referred to as the root of trust for Vault, as it allows the Vault to unlock all secrets stored inside it. This is why it is very critical to protect this unsealed key.
Right. So I guess now the question in the minds of our listeners is, how does Vault protect this unsealed key?
Yeah, in its default configuration, Vault protects the unsealed key using Shamir secret sharing. The unsealed key is split into n different key shares. Each key share is then provided to a separate key custodian. So there are n key custodians, each knowing a part of the key instead of a single person knowing the entire key value. A certain threshold of shares, also known as K, is required to reconstruct the unsealed key. The default value of n is 5 and K is 3. So at least 3 out of 5 key custodians are required to reconstruct the unsealed key. Whenever a vault is started, K number of key custodians must provide their key shares to recreate the unsealed key. That will decrypt the master key, which will allow Vault to decrypt secrets and fulfill any requests coming from authorized clients. This is a secure process, as no single key custodian knows the unsealed key, but there are a couple of considerations to using Shamir secret sharing as the root of trust for Vault. First, it makes starting or restarting Vault a manual process. Vault may need to be restarted at odd hours due to outage or planned maintenance activities, and using Shamir secret sharing as root of trust will require a human intervention during such events. Second, the unsealed key is generated using Vault's software crypto libraries. Many organizations have strict security requirements to leverage FIPS 140-2 Level 2 or Level 3 validated hardware devices to generate and manage such critical encryption keys.
This is really good to know. Thanks for sharing that. And as you have mentioned, many organizations require an automated unseal process, and a hardware-based root of trust can help meet the compliance requirements as well. And this is where Talos and HashiCorp have worked together to provide an enhanced HSM-based root of trust. Can you tell us a little bit more about this integration works?
Yes, the organizations can leverage Thales Luna HSM as the root of trust instead of Shamir's secret sharing. In this configuration, the responsibility of securing the unsealed key is delegated from users to a highly secure and trusted Thales Luna HSM. The unsealed key here is generated and stored only within the secure boundaries of a Luna HSM. At startup, Vault will connect to a Luna HSM via PKCS 11 API and ask it to decrypt the master key. As this process doesn't require any human intervention, it is also referred to as automated unseal for Vault. The unseal key also never leaves HSM and hence not subject to unauthorized access or leakage due to a human error. Now, let us review some of the benefits of leveraging Thales Luna HSM as the root of trust versus Shamir's secret sharing. The first benefit, as we discussed, is automated unsealing. It also improves the Vault's security posture as it eliminates any human errors around securely storing and managing Vault unsealed keys. Second, Luna HSM is a FIPS 140-2 Level 3 and Common Criteria certified device and meets the most stringent security standard for generation and management of encryption keys. This enhances the root of trust security for Vault and all the secrets stored inside it. With HSM as the root of trust, Vault can also supplement its system entropy with entropy from Thales Luna HSM. This can be quite critical for organizations where alignment with cryptographic regulations like NIST SP 800-90B is required, or augmented entropy from hardware true random number generators are desirable. We typically see this as a requirement for many of our government or financial services customers. Vault can also leverage seal wrapping functionality from Luna HSM, where it will store its critical security parameters in a manner that is compliant with key storage and key transit requirements. So in a nutshell, Luna HSM-based root of trust allows an organization to gain better security posture for secrets stored in the Vault while benefiting from a highly automated operational workflow.
Thank you for walking through this with us, Chintan. So let me see if I can summarize. Typically, as we know, security hinders automation and scale. And so this has been avoided really at all costs until required by developers. Additionally, we're seeing the need for open source, APIs, CLI, and a broad ecosystem to ensure a strong digital innovation for enterprises. And so these things have been a challenge in the past. And now with the combination of HashiVault and the Thales HSMs, we have a strong partnership that really empowers organizations to meet their automation, security, and compliance requirements, such as FedRAMP, GDPR, PCI DSS, digital signatures, code signing, and data encryption. And together we enable the vision of DevOps in a secure and efficient manner with a foundation of digital trust. And to put this all in the context of the global pandemic, IDC have found that teams practicing accelerated application delivery and DevOps were in the position to use software innovation and agility impact their response to the crisis. They were able to better roll out new releases in a much shorter time and help drive the shift to a digital business. So we hope you're staying safe and leveraging Hashi and Thales to support your business plans in 2021 with our combined foundation of digital trust. Okay, so with this, we reach the end of our talk. I hope you found this helpful. And if you have any questions, please feel free to reach out to Hashi team at hello@hashicorp.com or the Thales team at cpl.thalesgroup.com. You can also feel free to send Chintan or I emails, and we'll be happy to respond and follow up. Thanks again for your time, Chintan, and I hope people have enjoyed this. Have a great rest of the day.
Thank you, David.